Welcome once again to another episode of the SMC Journal podcast. This is a show that's all about software engineering in today's modern IT, and we cover a lot of different topics on this show: testing, tuning, observability, security, AI, and more. I'm Scott Moore, your host, and I really appreciate you joining me today. Everybody talking about Kubernetes this and Kubernetes that. As a performance engineer, the one thing I want to do with Kubernetes is figure out how to make it scale, and I'm talking about every piece of Kubernetes. And I'm going to talk to a guest who has done a lot of that, especially tuning the applications that sit on Kubernetes. A lot of people having problems with that today. So we figured we would try to make life a little easier for you by discussing that. Before we do, let's talk about the sponsor that made this episode possible for you to watch. This podcast is sponsored by Saltworks Security. For almost 10 years, Saltworks has delivered world-class application security services and products designed to help enterprises secure their applications from policy to production in an ever-changing security landscape. They're the makers of SaltMiner, an application security management platform designed by security professionals for security professionals. SaltMiner aggregates and normalizes the issues found by many different solutions and enriches that data with business context. SaltMiner gives team members from the C-suite, security, and development teams the ability to manage their application security program through customizable views. The Saltworks SaltMiner Community Edition is a free penetration testing management and delivery application. It provides teams with custom reporting for potentially thousands of end users, red team support, and the ability to manage new and retesting of engagements. SaltMiner Community Edition also allows teams to enforce both testing methodologies and custom vulnerability databases for consistency in engagement delivery. Check them out today at saltworks.io. Eli, welcome to the SMC Journal podcast today. It's so good to have you.
Thank you very much for having me here.
Well, today's topic, we are talking about Kubernetes, and I want to go through it kind of layer by layer and application by application. And I wanted to talk to somebody who has a lot of experience with Kubernetes, figuring out how to make it scale. Where are the problem spots and what are the performance issues that customers are having that they're having to deal with on a regular basis? And my understanding is you've got a lot of experience with that. Could you introduce yourself to our audience and what you do and your experience with Kubernetes?
Yeah, so my name is Eli Berger. I'm a CTO and co-founder of PerfectScale. And prior to that, for many years, I've managed DevOps and infrastructure teams. I established large-scale SaaS systems, mainly based on the Kubernetes in recent years.
And so what are the biggest things that you deal with on a daily basis when it comes to Kubernetes and performance? Like, what are the most common complaints? Pick the first one or two things that you always hear about.
Yeah, so we basically, conceptually, we divide the journey of your Kubernetes adoption into three phases. This day zero, this is where you plan everything. The day one, where you setting everything up. And day two, where you actually deployed all of your applications. And from now on, you're managing your entire infrastructure. This is something extendable and gets with you as you grow. So the biggest struggle that we see and solve is actually the day one and day two. They have their own learning curve, etc., etc. But eventually, they ending up. The day two operation is something that remains with you for a very long period of time and have his own bunch of problems.
You know, what I've been hearing in the market, because the cloud is now under a microscope about costing so much. And those companies who are either cloud native from the beginning and started their application being deployed on Kubernetes, or they're starting to migrate over, they're starting to see these bills. One of the biggest things that popped up immediately was we're trying to be conservative. We don't want to run out of resources, so we over provision for the Kubernetes cluster, and then we end up paying a lot more money for stuff that's not always working that hard. So is that a common thing that, hey, we've got this, we really don't know how much to give this, and we're spending way too much money. How do we reduce that cost by optimizing? Is that one of your biggest problems?
Yeah, Scott. So you're absolutely right. That's one of the biggest problems, and the reason for this problem is mainly, as you mentioned, this is fear. Like, we don't really know how much resources our application going to consume. We don't know how many customers we will have. We don't know how frequently they will consume services from our application. So to overcome that, we over provision, our developers over provisioning, and this over provisioning eventually it may be small numbers, but it sums up to huge bills. And one of the biggest struggles, or why it's so time consuming and so hard to figure it out, it's ephemeral and distributed system. So you need to tune hundreds, and if not thousands, of parameters and make sure over time, but that those parameters are tuned up perfectly. If you under provision them, the results that you have is out of memory, CPU throttling, underperformance, latency, etc., etc. And that's the main reason why everything is extremely over provisioned.
Now, I've been in IT for 30 years now. This problem doesn't sound unique to Kubernetes to me, right? Because if we go back to any application before Kubernetes, we didn't necessarily know when we were going to get a point load of a bunch of people. We didn't know necessarily how many resources we needed for our application until we actually hit that problem. And this was with bare metal hardware, on-prem servers. So what did we do? We started doing capacity planning. We started doing load testing and stress testing to see how far we could push it on individual servers to know how far we could scale. We started doing modeling for, hey, what are we actually seeing in production today, and started building out those perfect storms. Am I crazy, or does this shouldn't this work for Kubernetes as well? Shouldn't we apply the same principles and standards to that, or is this a whole different world?
No, on one hand, you're absolutely right. The problem sounds very, very similar. We have a one server. So we can build a dashboard and we can observe every important information around this server. But at the moment that we have 10,000 servers, we multiplying this dashboard 10,000 times will not give us any meaningful information. There is two contradicting forces. On one hand, you want your development to run as fast as possible. For that, you're breaking up the application to many tiny pieces. And those pieces, each of them have its own velocity. So the entire pattern of let's do the performance and load test is very fine and it works, but it's time consuming. It's very hard. And you need to do, like most of the organizations that we work with, adopting CI/CD, because without CI/CD, you practically cannot run software in Kubernetes. So it means that you have tens, if not, you have tens of changes for each and every application every day. And running those load and performance tests could be, in many situations, time consuming. So instead, the actual pattern that we meet today with many of our customers is your best playground is your actual production. Do it there.
I see. So, okay, so let's just kind of break this down a little bit. I've got a graphic that I'm going to bring up on the screen. I got this directly from the Kubernetes documentation. All right, what this does is break out. This is what Kubernetes looks like, right? You have two main layers there. On the right-hand side, we see the control plane, which is made up of various components, and each one of those has a purpose to manage the clusters. And then you have the nodes themselves that have the application built on that. So my assumption is that if I'm a performance engineer, I'm going to want to look at every single one of these layers, try to figure out the weak point, try to test out and see where are the spots where we either have to throw more resources at it, we have to load balance between multiple pieces of infrastructure, or we have to tune specifically some piece of it to make it perform better, or rewrite some of it in some cases, right? So if we're looking at this and we're deploying these applications in Kubernetes, what are some of the first things we look for on how to make it well performing without over provisioning these resources?
Yeah, so we can divide this problem into two pieces. So first piece is the control plan itself. The control plan itself is responsible for scheduling, responsible for networking, responsible for all the underneath orchestration part. It have its own part of or its own piece of performance problems. However, in most of the cases, when if you are using managed Kubernetes clusters, you will not face those problems. In general, if you're facing those problems, the first one is coming around the TCD performance. This is where you want your hard disks to have much more IOPS, use SSD or something like that. But this is kind of a side problem. The main problem is the applications that you're running on top of your machines. Let's dive a little bit deeper around those gray boxes of the nodes. This is where all the magic happens. So this is where our applications are hosted. They are machines like virtual machines or cloud instances, and your application, you running your application on top of those machines. So eventually you want to make sure that those machines have enough resources to host your application. And since you're sharing multiple applications on the same machine, you need the orchestrator to make sure that all the applications have enough resources. For that, Kubernetes have four practical configurations. The first two is the requests, CPU requests and memory requests. This is your estimation of how much resources you would like to have reserved for you on the particular machine. Then, when you schedule the scheduler of Kubernetes looks at the total amount of allocatable resources, remaining amount after some application already allocated some of the resources of the machine, and if machine have enough resources, your pod will be scheduled there. The second piece is limits. This is where you're limiting your application to not overconsume the amount of resources and kill the entire machine with all the applications in. So there is two types of resources: the memory limit and the CPU limit. For memory limit, it's very simple. It's like think of it like a safety valve. This is where your application going to be killed instead of killing the entire machine. For the CPU limit, it's much more complex than that. Many people are mistaken, and like weekly basis, I'm meeting people who saw that the CPU limits. If I'm limiting my CPU to number two, it will mean that I will be limited to 2 cores of CPU. However, that's not the case. CPU is compressible resource, and it work. So instead of limiting the entire CPU, we're limiting basically the CPU time, creating unnecessary throttling, and we need to be very, very careful when using the CPU limits at all.
So, question for you. This is something I just personally wanted to know. We're putting all this stuff in containerized way. We're on the cloud that is on virtual machines that are then on physical machines. So you've got something inside of something inside of some. I've heard of putting Kubernetes on bare metal. Is that a better option to remove that layer and make it more scalable so you don't have to deal with that middle layer, or is that a problem?
No, it remains the same, the exactly same problem, because you're hosting multiple containers with multiple demands and multiple capacities. On top of, eventually, you need to host it somewhere. So, regardless of what type of hosting you will use, the scheduling will remain the same. The problem will remain the same because you're sharing resources between multiple applications on top of same machine. So, you need to set the boundaries and you need to provision guaranteed resources.
When you're helping customers optimize their applications, are you using your own built tools that you've come up with? Do you use tools like Akamai or Stormforge or some other that goes out there and looks at the configuration and helps to kind of as a watcher and tunes the application over time to find that perfect fit, or are you doing something else?
Yeah, so At PerfectScale, what we basically do, we observe everything that happens in your cluster. We observe the application layer, we observe the infrastructure layer, we understand the impact, we understand the consumption, we understand the behavior, we understand also potential impact of the changes. I will give you an example, right? When we talking about so we're looking basically for two types of problems: the under provisioning, which is obvious, right? You either have low performance of your application or your hardware is struggling. That's the one type. It's the easier one. The more complex one is the over provisioning, right? And here I'm talking mainly about the impact. For example, we have something very heavily over provisioned, but this is a job running 1 minute in a week. Should we tune it? Probably not, because it will not give any impact. But on the other hand, we may have a slightly over provisioned application, like 10 or 15 or 20%, but we have 200 replicas of those. The total combined impact of those will be huge.
I understand.
Yeah,
So,
so we're using our proprietary tools and our proprietary AI-driven algorithms to understand how those applications behave over a long period of time, like months, and what would be the sweet spot for the configuration in one hand to constantly make sure that your application have enough resources to run and doing the best possible performance, but at the lowest possible cost.
I'm glad you mentioned AI because that was my next question. This will be the last question for you, but it's an important one. Uh, it seems to me that as complex as Kubernetes deployed applications get, especially when they get very large, there's so much to it. It seems like AI might be the one easy button that we can press, or at least to make it a little bit easier to find these anomalies, find where to tune it faster, and just get the work done. Because otherwise, it's going to take forever to get this thing right. Would you agree with that? Is that our future? Is AI? We're going to have AI help us get there faster.
Yeah, so AI actually helps us to breach the last gap. Okay, so like we have all the observability solutions in place, we have all the monitoring solutions in place. They can provide us with the information about each and every layer, each and every piece. But the problem is that the data is not equal the answer. Like we have all the data is there, but someone need to take care and analyze this data. Someone need to find and prioritize actions. Someone need to understand the impact of those actions that will outcome analyzing this data. And eventually someone need to do it all the time repetitively, because everything is constantly changes. The application constantly changing, the topology, the customer demand, etc., etc.
Awesome. Well, I wish that we could talk another 30 minutes about this because I find this fascinating, and I know a lot of people are struggling with this right now. If somebody looks at this and says, hey, I'm actually having these problems and I can't fix them, I need some help, how could they go find out about PerfectScale, how to get some help from you?
Yeah, so perfectscale.io, this is our website. Our setup is very fast. It takes 5 minutes to set up the system. And we are SOC 2 certified, so it's secured. Uh, Go ahead. We help our customers. We love our customers. As part of 30 days free trial, you're also getting the free optimization session when I'm helping, and a few more engineers that we have helping you to analyze your own cluster on top of our system, see and evaluate all the findings, and see how you can do it constantly and effortlessly.
Awesome. Well, thank you so much for being on the program. We'd love to have you back to talk about this more. Maybe we can focus on just the AI aspect of how things work with that, because I personally just would love to know that. But thanks again for being on the show today.
Thank you very much, Scott. It was a pleasure to talk to you.
So, what do you think? Was this good information for you? Will this help you in your quest to deploy the most awesome and scalable Kubernetes deployment ever? I'd like to hear your feedback on that. You can reach me very easily on most social media platforms. LinkedIn is my primary one that I use. However, if you scan that QR code, it'll take you to my bio page. It'll show you how to get to me and all the web pages and all the shows and stuff that I do, including this site as well, this show as well. You can also drop me a quick email at heyscott@smcjournal.com. Would love to hear from you. If you do like this content, it would be great if you liked and subscribed to our channel on YouTube. It makes a big difference, helps me figure out if I'm providing you with the kind of value that I think that I am and hope that I am. Would love for you to be part of our subscriber base. So until next time, when we cover another awesome system engineering and software engineering topic on the show, this is Scott Moore saying thanks again for watching, and we'll see you next time. Bye-bye.